Hello everyone, how all are you? Hope all are fine and doing great in their coding journey. So let's start our today lecture, which is based on the Q data structures, as we later discuss about the stack data structures. So let's continue without wasting any time. So open our previous DSA folder that we used for full data DSA course in it, and I already built a file of q.java, which is our next lecture, which is lecture 5. So now I comment, starting with comments. I explained you everything about q data structure, and the q data structure is nothing other than it is simply defined as the linear data structure. As we discuss about, the stack is also a linear data structure. It is a subpart of linear data structure. So it works in open both hands, and the operation are performed in FIFO, that is first in and first out, and in stack we observe that this works on the principle of LIFO, that is last in and first out. So it is some bit difference in stack data structure. So it's also a very good time complexity and space complexity and compared to stack data structure, but it has some problems in DQ data structure that I told you very soon. Now this is the simple definition of Q data structure is defined as a linear data structure that is open at both end and the operation are performed in FIFO, that is first in and first out. Like we also saw a practical example in the real world, that is we observed that outside the cinema halls and outside the railway platforms we observed a great line of peoples listening in the for tickets, taking the tickets, and simply that is same as queue data structure. Also we discuss about the applications and also the functions. A queue data structure is like a line waiting to purchase tickets, where the first person in line is the first person served. That is, which person come first, and it is on first served. So we discuss about the functions of DQ and queue data structures, like NQ. DQ is empty, is full, and peak, and three are the same as previous one that is used in the stack data structures, and the unique one is NQ and DQ. They all are different from the previous data structure, that is stack data structure. So we discuss about what is NQ and what is DQ, what is empty and what is full, and and this is somehow relatively that NQ means that add the element and DQ means removal of the element. Is empty, as we later discuss about, that they check the statement that it is true or false. We use loop commands, that is if and else statement in this, and also we use is if is full statement for checking purpose, that is the our queue stack is full or not, it gives in boolean form. And also peak, we get the value of the front without removing it from the actual queue that we build up in earlier by putting the values. So I write it in. So these all are the functions of queue data structure, that is NQ. DQ is empty, is full, peak. Now we discuss about the characteristics of a queue data structure, that is queue data structure can be handle multiple data and we can access both ends, that is front and last. And also we discuss about the technical term in this is, and that is front, and the second one is rear, which signifies the value of DQ means deletion, means removal of any queue element, and a rear means NQ, which means insertion of any value in the queue. And also they are fast and flexible. All queue functions are well and good and manages the data in very efficient way, and their time complexity is constant, so it gives a better result in performing the output. But the main disadvantage is that the NDQ functions, which is very slow because its time complexity is not constant, it is 0 log n. And also we discuss about many other algorithm to get the final better code results. but somehow it is also important to know that how it is work in real life applications also. So now we discuss about the by taking an example to see what's the functions they do and how the boilerplate of these codes run and queue data structures that we already seen in stack data structures. Simply we see every functions line by line in our example code. So let's start by coding in Java. Now first of all we build a class of function of dq name, and then we import some integers values and allotted them a fixed initiation point, and then finally we terminate the conditions that is I use size and I give value of 5, that is I give the value of 5 in the queue functions, and I later on give 6. It is not included in the queue, only it take 5 function 5 elements. And now I import items in it. We use new keyword in this. Java is very case sensitive, so aware about what is uppercase and what is lowercase. Otherwise, an error shown by the Java compiler and our code does not run effectively. As I said you that we use new technical term that is front and rear in it, and also they are nothing other than integer data type. Now we use curly braces and we allot a value for front and rear, that is -1. Also we give a value of rear -1, then terminate the condition, and now we move further forward. Now we use boolean and then is full command, because our main motive is to learn every single components of the queue data structure. For better clearance, we use if and else in this. Now enter front, then is equals to 0, and also we use double end command and rear, and this equals to size and -1 in this, because rear is backside and front is upside front side. So we eliminate one element from it, and now we use again curly braces for entering in the loop and then return true because it is a boolean type, and if this satisfies then it shows true, otherwise it gives false. And now it's time for empty. Now use similar way, that is boolean is empty, then use parenthesis and curly braces, then use if command, -1, and then return true for this. If this true, then it shows true, otherwise we use else command and then it return false. Now we use void and enqueue. We use integer and allotted a name for it, that is element. I use you give any name, and we use again if command, and use if full, then parenthesis, then curly braces, and now we used to write in this way that we use if command. Now this is repeatedly entered by if command. Then we use system.out.println for print command, and we use this for new line command, and the queue is full, and we use else for entering into the loop if front is equals to -1 and front is equals to 0. Real plus plus, it means it simply approaches the other elements of the queue. And now if item real is equals to element, then it's and we print the element, and then plus element then is inserted. And when you see the actual code, you know a better understanding that what is happening in there. Now I format the document for better visibility. And now in this way we also use dequeue command. In similar way, we allotted a value of integer element, and then we use if command, if statement, and then use as empty, and we print out in the next line the queue is empty, and then return -1, means this is the value of queue, and this shows simply the index value of element. And we use else also for inner loop, then we use element is equals to items, then front, means it shows the value of queue from the frontwards. And now we also use if, and then we put a condition for this front, if greater than and equals to real, then it shows front -1, and then real is equals to -1. And we use another loop also, so we use else command and then front plus plus. This shows that if this conditions simply satisfies the whole procedure, then it shows the other elements, and then other element, and then other element. And simply if it is not follows that, this shows the print command the element, then plus element, then it's deleted. Means if we use to delete a certain element, then it shows this this type of coding. And now it's time to display our queue. So we used to display in this way, use parenthesis, and then use curly braces, and use integer I, then end it. And now use if, then use is empty, and then again use curly braces, then print, use, and then we display our actual queue stack, queue data structure, which is I allotted the integer value I, and I shows that if is empty, then print the queue is empty, and else if this condition satisfy, then this shows this, and if it does not satisfy, then this shows that the element of the queue are, then it shows four conditions, and it is simply kind of a loop. Then system.out.println, then it shows the type element and the items array shows detail wise detail by giving a space in it. Now it's time to use our actual boilerplate, that is public static void main string args, then we use queue input, then again q is equals to new, then q, then semicolon, and this way we write up a main boilerplate which is recall in our terminal of Java. So we write it in public static void main string args, then brackets, then curly braces, q input q is equals to new q, and then we use for, that is a loop function. Then we initiate the value of I is equals to 1, which is less than value of 6, and also it shows by again and again, and then we used to input q dot nq, then it shows I into 100, that is it shows the value of elements which is multiplied by 100 in every element. So we use this procedure in the loop for getting multiplied by every element in our queue, and now we print the functions, that is the q id is identified as, so it give a unique id for q data structure, and also the input dot q that and q, and we put a element of 6, and then we use input q dot display, then it shows the value of q, and then we use to dq, that is it's remove one element from our actual dq, and then it shows the display, that is our final input function. And now we run the code and observe that what's happened in our terminal. So let's watch. The element 100 is inserted, the element 200 is inserted, the element 300 is inserted, and this shows 500 is inserted, and ids of a queue is identified as this one, and also it shows the queue is full as we used is full, and is empty also the element of the queue are, then it shows is currently, that is 100, 200, 300, 400, and 500. And now in this way we eliminate using the front function, and we delete 100 from upside of the queue, and then it shows the resulting queue of our queue data structure. And this is the overall code for today lecture. So we discuss about everything that we discussed earlier, that is nq dq is empty and as whole and weak also. So you also try the whole code in your same pc, so that you can understand each and everything very clearly. So thanks guys for watching till the last. Please subscribe my channel, like it, comment it, and also share with your friends, and also support me and love from you all. Thank you.